Um, Good morning. My name is Alak Ray. I work at the Tata Institute of Fundamental Research in Mumbai. Um, I will be talking today on supernovae and gamma ray bursts. I'm particularly pleased to be here today with you at the Nehru Planetarium, um, uh, where my host is Dr. N. Ratnashri. Uh, It's particularly pleasurable because Ratnashri and I had worked a long time ago together on some research projects while she was at Tata Institute. Ratna was a doctoral student in TIFR in the middle 1980s and early 1990s, and I am really quite grateful that she has given me this opportunity to talk to you um, who are students and amateur astronomers who are interested in astronomical topics and who are associated with Delhi University or the Delhi area and Nehru Planetarium. So my talk will consist of essentially three parts. That on supernovae, and also associated explosive events which are called gamma ray bursts. In addition, I will also talk about some recent work that I have been doing with my students at Tata Institute and other collaborators across the world. Let's begin with the second slide. This is a picture that is taken by the Hubble Space Telescope of the quintessential, the most well-known supernova. That is a supernova in the Crab Nebula. This was an explosion which took place in 1654, and the Chinese sky watchers had a record of it. And only later on, in the modern era, people had rediscovered it. It was rediscovered by Charles Messier, a French astronomer, and it has now been looked at through all wavelengths, from optical through X-rays and gamma rays, and including radio wavelengths. And it's a rich source of information and teaching about how stars actually manage to explode. Next slide, please. Okay, now this slide tells you what people can hope to learn by studying supernovae. The supernovae enrich galaxies, which are clusters of stars with heavy elements such as iron, calcium, silicon, which are crucial to life. The calcium in our bones and the iron that is in the hemoglobin molecules that flow in our veins were actually manufactured in explosive events of supernovae, and these ultimately enriched our solar system, and this solar system later on gave rise to Earth and its living beings on it. So supernovae are actually connected with all of us in a very crucial way. They also lead to formation of new stars, meaning the explosive events help trigger formation of new stars. They are often used as standard candles, or rather calibratable standard candles, which are very bright, and therefore they can be seen across the universe, and they have been used to measure the geometry of the universe. Supernovae are actually the result of evolution of stars, and they can in fact even influence the evolution of the whole mother galaxy in which they are situated. Another important aspect of supernovae is that they are the source of energetic cosmic rays, and for a long time supernovae have been thought of the sites where cosmic rays get accelerated. Physicists were initially at a loss to explain, however, where the supernova's energy budget comes from. And we will see this as we go along. In the next slide, I have tried to give some idea about the various scales of explosions that take place in the universe, as well as man-made explosions on Earth. When you set off a chemical explosive, the kind of energy that is released per unit mass is typically few electron volts per atom. And this is, this can be in MeV scales, it's typically 1/1,000,000th of an MeV per atom. Whereas nuclear explosives, when they are set off, release typically 1 MeV per nucleon. There are nova explosions, which are thought to be explosions on white dwarf stars, found aplenty in our own galaxy and in some neighboring galaxies as well, where the energy scale is again a few MeV per nucleon. And these are also the energy scale of thermonuclear supernovae. There is a class of supernovae which is called thermonuclear supernovae, and there again the mechanism that powers those explosions are runaway thermonuclear reactions. Separated from them are these so-called core collapse supernovae, which are extremely energetic and far more energetic than all the other classes that I've described so far. They release 100 MeV per nucleon, and typical total energies which are released from the explosion of a star is 10 to the power 53 ergs. If you compare the largest thermonuclear explosion on Earth that took place was carried out by the erstwhile Soviet Union on October 30th, 1961 in their region called Novaya Zemlya, and the amount of energy released there was 58 megatons of TNT. Okay, and 1 megaton is typically 4 times 10 to the power 22 ergs. Okay.